I got some packages in the mail. 1-inch collets. These are some bearings. Okay, well, we got 2 of those. This is 1/4-inch key stock. This is number 50 roller chain. Now, if I haven't already talked about this, number 50 roller chain is the same as 530 motorcycle chain. And this is 10 feet of it. Plenty enough for what we're gonna need. Idler sprocket, number 50, 1/2-inch hole in the middle. And these are sprockets. This is a 12-tooth sprocket with a 1-inch hole in the middle. 1-inch shaft with a 1/4-inch key slot in it. This is our new Jackshaft, and the idea is that we have a bearing on one side. And then we have another one of these sprockets on the outside. Anyway, so this is our Jackshaft. And obviously, to keep this stuff from rotating, we have this key stock that'll go in this channel, and it'll lock this guy in place and this guy in place. So this will be what the motorcycle is connected to. This will be what the rear transmission is connected to. And that's what this chain will be doing. This chain is to do this loop right here, and the chain will go back to the rear, and we have this idler sprocket that way so we can tension this rear chain. This guy doesn't need to be tensioned by this because we can adjust this forward and back with these bearing blocks. A lot heavier than I thought it was going to be, but the options are pretty much do the 1-inch or the 5/8 inch. And well, we have 80 horsepower, so I figured we opt up to the 1-inch just to be, safe about it. This was about $100. Let's see how this fits up on the motorcycle frame and how the chain is going to fit to the rear transmission of the Polaris. So I have this all generally in the order that I want it to be. So this is a bolt. I think it's 1/4-inch, and this hole is 5/8 inch. So obviously there's a big difference there, but just for mock-up purposes, this threads into there. Put this bolt over here. I'll get a bushing for this later. Really an issue. But let's just say for the sake of doing this way right now, we have this bolt here. Goes through there, and this can go up to somewhere over here. Tighten, loosen this, and that'll adjust this down and up, and that should tension chain as well. So obviously if we push it out, it'll tension the chain that way. Pull it in, it'll give it some more room. And this guy right here, we can adjust in and out where we want this to go back to the rear transmission, which is just out of your view down there. So here's our transmission input, chain output. This is way farther in than that, and that is because here is the inner part of the CVT that originally went on there. That just snaps on there like that. And then here's our motorcycle rear sprocket, and that will somehow get mounted to here. So when I put this here now, put this right around here-ish, these are now in line, which is great, because now we have all of this leg room. It's better than what we had before, which is having the chain go right here. Chain here, kind of where your legs would be, or out here. The pedals are gonna be like here-ish. So this is gonna be more above your feet, and I'll have to make kind of a wallish kind of thing that goes here. You can't get your leg accidentally snatched in the chain that's running literally right there. Part right there? Yeah, this one. So this is from a while ago now. This is the old CVT driven side. Obviously has had some modifications to it, and there's some extra little pieces that are still hanging on there, mainly, very sharp bits, and it's not exactly clean. So if I intend of adding anything to this piece, I need to make sure that's a little bit safer and a little bit better. And then when I measured the diameter of this shaft, it looks like it's been ground at least. Yeah, you can see there that's 1.5000 inches. Now these calipers don't actually do 4 decimal place precision. You can't trust these things for that. But for it to say that right off the bat of just clicking it in, I'm gonna say this is pretty safe to bet 1.5 inches. And you can get bearings for 1.5 inches. And the reason why that's important is with this much stick out and putting a sprocket this far out on it, there's a lot of leverage on the transmission. There was a belt around about here-ish in distance out, but now we're adding force about double that distance out and doubles our leverage on the shaft and such. We don't want it to break, basically. So what I'm thinking about doing is getting this all machined off to extend it this a little bit more instead of just cutting it off. I also realized that before what I wanted to do was put this sprocket, the original sprocket, off of the Suzuki Bandit and just kind of mount it, there. Downside, obviously there's a handful of downsides. The original Suzuki Bandit gearing ratio, ignoring the gearing ratio that's in the transmission of the Polaris 500. Now, after doing a little bit more reading, I don't want to put this on there. There's a significant gearing reduction on the Sportsman. So I'm looking about getting something a lot smaller, which is great, which means I don't have to use this. I can put that back in my pile of other stuff. I can get the smaller sprocket, put this on here. Now that's great and all, but I kind of can't put that on here. There's this giant blob in the way. Guy in Home Depot, and he said that he had a lathe, and I don't have a lathe. And so last night I was looking at the machine tooling to get a lathe, or, which, you know, I can't afford, or put it in like an index or, you know, something like that, and just have like an end mill slowly chop off all of it. So much easier to do on a lathe. And we have an appointment tomorrow to meet with him to see what we can do about this. So I cut off all these big chunks, so we can see now that it's a lot more round than it was before. So now we can go over and chuck this in the lathe. Look at that. Just got a little spring left.
Yeah. It's still a thick portion of it that's going to be glued to the front face.
Oh, yep, she popped right off. And, well, look at that. That's a little confusing. This is the side that we removed a bunch of that material from, and it turns out there's a thread under. Everything I've looked online for trying to find a part like this, I haven't found just this sold by itself, so I didn't know that this thing actually had its own threading in here. I really thought that it was just a press fit in there because I haven't had any reading material about that existing at all. I haven't seen any part diagrams of that, and, well, that confused us both when we were using the lathe and trimming it off, and then all of a sudden threads appeared. So we didn't cut the threads off. They're all intact and they're all good, but it is certainly a little odd. Oh, really weird size. The metric equivalent to that is M39 by 1.5. That's a really weird number. You have a chain that is pulling that way. It's just going to unthread off of this shaft, whatever nut we put on, which means we need to do some kind of key, or we need to re-Loctite it, which is probably why they don't really tell you that this is threaded, because they don't want you to unthread it, because once you do that, well, CVT really isn't going to stay on the outer half. So now you see my dilemma. So do I buy an overpriced nut, screw that on there, and then weld like a plate to it, and then put a sprocket on that plate? Do I get this trimmed down to 1.5 inches and then just weld a sprocket on there? Or do I cut it down to 1.5 inches, cut a keyway into it, put sprocket on there, and just hope it stays on, basically? I don't know. Yeah, can you see that? That's diff fluid. And at that, dirty, muddy diff fluid, which is, we don't want that outside of the diff. So why is it outside of the diff? Well, pretty sure that's my fault mixed with it being old. These are the axes that come out of the spindles. And originally when I took off the spindles and this whole thing, those popped out. Since these have been out and they flop around a lot before the steering went in, these would get pinched into the side of the tire here. This thing would roll back and the tire's pinched in. These would bind on that and it would put a lot of force on the differential side to side, which they're not really designed for, obviously, because they shouldn't have side to side loads. So the seal on this side is leaking. And you may think, oh, that's just a little bit. Well, that's just like leaving it for like 2 or 3 days. It's been like this for, I want to say 2 or 3 months it's been leaking. So obviously the seals need to be cleaned and replaced. So I have to get that diff out. So let me do that real quick and get it out, fix it. Now that you can see that our engine is floating, you can see here's our diff just sitting in there. You're gonna get that bolt, that pops out this front engine mount. Then we can get the diff out because it has to come right up. And yeah, I really don't like having this thing float above my hands. I already removed the rear mount. Yeah, get the motor up a little bit higher. We still have to get that U-joint out. Honestly, I have no idea how to do that. Oh, right. Spinning the back tire spins the drive shaft. Right. Hey, but at least it's now in a spot that I think I can get to the roll pin. Just want this to be known. I have no idea what I'm doing on this part because this is a pretty big roll pin. Yeah, this roll pin is a lot bigger than I thought, so I had to get a bigger awl. But with enough hammering, it comes out. There's our roll pin. Now if I'm lucky, this should just kind of pop right out. There we go. Just like that. Yeah, you can see that there's a giant stream from right here all the way down. So somehow, I have to get that seal out. I kind of feel like I shouldn't be able to hear like a grinding noise inside there. It's fairly smooth, but I do hear a noise. Pop this open and see what we can do. So I think we just have to remove these arms because they're just going to be in the way. And plus, they need to be cleaned bad. So let's get those out. Oh, yeah, and that's just straight up water coming out of this. Okay, well, let's get some gloves on Oh, that's just straight water. Oh, that's bad. Let's try and find this hex key. Yeah, that's what it was. Just really gummed up. Time to call the bolt extractor out. I fought with this thing for way too long. I've drilled out that entire hole all the way through so that it never came out. I kept on trying to use the screw extractor. It didn't work. Anyway, so that was the last screw to get out, or get out. You can see we have this hole pattern right here, the 6 dots, and I'm pretty sure this is threaded on, so I need to like twist this out. I tried to find a tool online, you know, to see if it was like, you know, 20 bucks or whatever. I'd buy it for that cost at this point, because you can't really do this any other way unless you have that tool, because this is soft aluminum and it just chips out if you hit it with a screwdriver. I tried a few different ways. So since I can't find one online and I can't hammer it out, basically, I need to make a tool to open that up. And nicely, the people who made the hole pattern here made it the same hole pattern as the front, and we need to take both of those out. And I realized I have a full bag of M5 screws upstairs in a really long size. This is from making the CNC machine. So coincidentally, the thing that makes the CNC machine is also what we're going to be using to make the tool to open this up. So this is the basic tool. We have to have this offset right here so that it can reach inside the indent of the right hand side. Obviously we have our 6 holes here, and we have a nice long handle. Additionally, we have the hole cut out here in the center, that way so it can go around the axle outputs, inputs like that. Really basic. Really, there's only 2 critical dimensions on this whole thing, and that's the distance between 2 of the holes and the diameter of the hole, and that's it. And I made it 4.9 millimeters for the actual hole to get drilled out, so it'd be a press fit getting those M5 screws in. That way so, you know, we don't have anything really wiggling around, and it takes some of the slop out that the wood's gonna have when we try and spin this thing, because, you know, the wood's gonna flex a little bit. So if we go over to manufacture, see that I've already done all the steps. So we have our face operation basically for the handle, the top surface face. Gonna do cut out that hole in the inside. It's tabbed so that doesn't fling around. Then we have the outside contour, also tabbed. And then we have all of these holes right here as well. All 4 of these first operations are done with a 1/4 inch end mill, and this last one is going to be done with an 1/8 inch, just because, well, 5 millimeters happens to be less than 6.35 millimeters or 1/4 inch. So if we bring this over to our CNC machine, you can see that's our part. And so now I just have to locate that corner. I've already trammed up our piece of wood. It's all clamped down. I've already found our corner, and basically now it's just turn on the vacuum and hit start. Okay, that looks pretty good to me. I like that. And there we go. Now we got our 6 little spokes like that. Oops, that was the vise. My bad. And yeah, this should just work now. So now that we have our 6 pins in there, put this up here. Yeah, look at that. That just seats in there. Oh, that's so nice. I am just going to hammer it just to make sure they're fully in. Yep, and we can see that we clear there. So look at that. So now this should just like... Oh, am I gonna... Not gonna lie, kinda thought it was just gonna spin. Yeah, I guess not. How do you do this? Am I tightening it? Am I going the wrong way? What's happening here? You know, I could remount this and then try it. That's a good idea. Well, it looks like the camera just deleted that file, but whatever. I bolted up the differential to the frame, and it is spinning after a lot of hitting it with the mallet, and I've got it around to maybe 3/4 of a turn now. Oh my god. It's extremely difficult to turn, but it is slowly coming out. Oh my goodness! It's working slowly. Yeah, I can't get this on there anymore. Okay, well, I guess back to the desk. I don't know what's up with this camera, but it just stopped recording out of nowhere again and corrupted the footage. So anyway, let me reenact this for you. And it popped out. There you go. Now you're caught up. Yeah, you know, I would say that's why I couldn't get this undone. Look at all that. What is that? Anyway, The tool held up, and it's fantastic. I'm probably going to link a file for this, so, because I couldn't find one of these online, so, you know, might as well share it. Also, big old bearing. Yeah, it looks like a chocolate milkshake and absolute disgusting. What is that? Oh, you know what that might be? This thing was leaking at one point, and someone thought they could fix it with plumbing putty. Yep, as usual, chocolate milk. Okay, well, I don't know how the heck I'd get that bearing out of there. And then there's a shim. Okay, oh, there's 2 shims? Oh, thin shim on outside, no markings, the hole in the middle. It's not big enough to go around the bearing. However, this one was. This is all gonna get cleaned, so don't worry about me setting this stuff down and stuff. This bearing, honestly, it feels fine. I have no issue with that bearing. So, one less thing to buy there. There is a needle bearing in here, and it sounds crunchy. It looks like I can pop that out, but I'm gonna order a new one of those needle bearings. Definitely a new seal for this side, because that's seen better days. And then absolutely, obviously a seal for the side that was leaking. Now this one, I think I'll order one. Yeah, I mean, heck, I can try and spin it right now, but I don't think it'll go well. While it hasn't been leaking from there, its days are numbered, let's say that. But yeah, I gotta clean all of this gunk out. All of this is gonna go through ultrasonic. Yeah, this O-ring, holding this on. Yeah, look at that. It's dry. Oh, actually, you know what? Oh, the side that was facing up is completely bad, but the bottom side's good. Hopefully I can get a new one of these. I understand now why in the parts manual this isn't considered an actual differential. It's considered a front gearbox because, yeah, there's no differential in here. It's just that's output and that's output, and there's no clutch or anything. It's just, yeah, that's it. But yep, I think it's time to order some parts. It's been around 2 weeks, and I just got some new O-ring, so it'll go around this new edge so we don't have that leak there. Additionally, I got all new bearings and all new seals. So these are 3 seals. There's one on this side, one on that side, and the one right there. So I am going to try and get that seal out. This needle bearing is that one right there, and I can see the smooth edge, so it looks like I need to flip this over, push it down. This little guy, I'm pretty sure, is what this helical gear goes into right in there, so I don't know how the heck I'm going to pop that out, but I imagine I'm going to be able to see more once that bearing's out. And then, of course, we got these 2 big ones. I imagine one goes up in here, but this one here is nowhere near as big as that one, so I guess that one is 100% staying. So yeah, I guess we'll find out where these 2 bearings go. Let me pop that seal out first right there, because that one looks like it'll be easier to get to. So I guess the next step would be this face out here. Okay, well I guess I'm going to try and screw this into the frame and then try and twist that. So I was going to mount this back up to the 4-wheeler, and then I realized I didn't have enough room in the front because, you know, the actual drive axle goes right into there. And then I realized, oh, what if I had a table, you know, that holes in it that I can mount this to? And I realized I have a welding table. So I just slide this on there. This is nice and bolted down. And I just whacked this like 3 times and we're in business. Are we sitting on the seal? What's happening? Oh, there we go. Ah, that's that bearing. Okay, cool. What that's for. Oh, and there's another one in here. That shaft is locked in there. It's just kind of like... Oh, yeah. Ooh, yeah. Yeah, do you see that? It's not supposed to do that. Okay, and now I see the other bearing, and yeah, there's just a pool of water in there. Okay, let's get this back to the desk and see where we can go from there. You see, that's a lot. This is significantly lighter now. I can still see part of the screw that was in there. You see, that's where the old one just has a little indent. Yeah, and that one's completely drilled out. Yeah, it's not far, but I definitely made a hole into it, which is fine. That part's solid. This O-ring right here, pretty flat, but I'm seeing way less gunk. Someone who did it last time must have ran out or something, but there's definitely some still in here, and there's a ton of mud in there. Let's get this hammered off, and then working on getting these bearings out. So I clamped this in the vise and just kept on whacking on it. Yeah, that took quite a bit of mangling to get out, but I'm going to sock it and try and hammer it down. This one has a little bit of wiggle in it, but not nearly as much as this one does. That one is bad. So it looks like that bearing went down to this circlip here. There's another circlip right there that needs to come off to get this bearing popped down. Okay, it looks like I'm going to have to do this one in the vise, but let me get those circlips off. Ooh, wow, that was more than I wanted to do, and it smells absolutely awful. Someone used like used motor oil or something in here. That That's terrible. Now you can see we have that one needle bearing down there. Oh, and that's why they include a hole there, I imagine, so you can tap it out. Back when I was in high school, they tore down one of the buildings, and inside one of those buildings was a science room. And so they gave away all the stuff that was in the science room, basically. And I remembered in one of the boxes that I'd brought home were a box of screwdriver heads. And they are the perfect size to fit in there. Like, the perfect. So, I'm gonna see if that works. Hey, look at that. Yeah, it's popping out. I cannot believe I remembered I had these. So I got it most of the way out. Okay, I got it out. All I do is I crimped on the pliers under there, through the hole. I clamped this into the vise and I just tugged the whole casing. And I think that's basically everything off of this. And yeah, so I'm going to stick this all in the ultrasonic cleaner, re-oil them back up, and then we'll reassemble it. So I just took everything out of the part washers. I spent, I don't know, like an hour or two cleaning up this. This looks way better in there. I used a plastic brush and also a wire brush. Went fairly well, and also some Q-tips when it, you know, need to get into the really tough spots. I got all that gunk out of all the thread. What really shows it is, see, the inside is fantastic, and especially this outer piece, which I got really, really nice and shiny and all nice on the inside. I also noticed there's like a burn mark on the inside of this, and it's either sitting water or the bearing, I don't know, got really hot in that one spot. The shafts look pretty good. Also note everywhere that there was a sealer bearing, and if I feel with my fingernail, the only one that catches is this one a little bit. Otherwise than that, I think we're fine. Oil this up with some 3-in-1 oil just to assemble it, you know, make sure everything fits nice, and then I'll fill this up. Okay, so I just bolted this down to the table. Sorry, I don't have much room over here. That feels super smooth. I mean, it needs some force to move, and I'm sure that's because there's like no oil or anything in the bearings right now. Probably because of all the new seals I put in are a little bit more stiff. I'm surprised the tool lasted that entire time. So now I just got to put in the drain screws and these little set screws that are here, 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 and here, and I'm not putting that rivet back. So I found on page 210 of the user manual, calls for in this gear case a GL5 80-90 gear lube, but I was reading on the forums and stuff, and I heard that 75-140 full synthetic gear lube is way better for this stuff, and you want to do 75W90 if you're doing something like that's in a colder climate, like this stuff, always the full synthetic, but I'm going to use this stuff actually in the rear transmission because it calls for 90, and I'm going to use the 140 in the front. And these both are the GL5 oil type. So basically it says remove the fill plug, fill up to the very bottom of those threads, which it says it's supposed to be 2 to 3 ounces. This is 32 ounce. Plenty of future oil changes. That spins way smoother. You know, it helps when you put oil in something, I guess, you know? Now I'm going to clean these monstrosities up, and then I guess it's time for reassembly. Okay, just did the first one. This is the, well, that says L, so this was the left axle. Well, it's still pretty, you know, old and beat up looking. It's still a lot better than whatever that is. You can clearly see that. So I got in there as much as I could. There's still some grease, you know, around the grease fitting and stuff. I'm sure there's still more, you know, I could get out. Chiseling, you know, I will get some more of this out in here, but I'll do that in a minute. I'll get this one wrapped up and that one wrapped up, and then we'll go over there. I think those look way better than they did before. Look at all that junk that's on the table now. There's also some on the wall somehow. So let's install this, and then we'll reattach these. I just spent the last 2 hours making this bumper you see here, so that looks a lot nicer. But the reason why I did that is to strengthen up the steering rack, because before, when I turned left or right, it would push this bar, and because this whole frame would like parallelogram. So this will stop that, and that's welded here, all the way around here. I did a nice rounding all through that, so that looks really nice. I also added this whole back plate here to strengthen this all up so this thing couldn't flex this way anymore. I even welded in some spacers. And the reason why I had to do that, now when I pick this guy up and I set it in there, well, you can see how close that gets right there. So I had to do this now, and I did it off camera because, you know, it's a lot of boring work, but it looks way nicer in my opinion. The steering rack will fit way better, and now we can put this in. So let's jump to a time lapse of reassembling this, getting the whole engine back on. So you can see how this boot is torn, a giant crack through right there. The other one's the same way. It's been like that for a while. So today I'll fix that because that's where the new axle needs to go, or new. So I need to take off the tire. I need to take all the spindle stuff out again, and I'll rebuild it on the table. So here's our axle that we just took off. You can see that boot is absolutely destroyed. So I either need a new axle or a new boot. Thankfully, I bought 2 new boots and new grease. I have 1 tube for each and the new band clips and everything. I'm just gonna try and get off these old boots and clips, reassemble this, get that new grease in there, and we'll essentially have a new axle. Boots are on. These ones are super duper tight. These 2 are not the tightest, I will admit. And the reason why is these 2 need a certain type of tool that I don't have. And why don't I have that tool? Well, when I purchased these had a different picture of a different type of connector that I do have a tool for. And so, well, that basically screwed me over when, you know, it didn't come with that kind. So maybe in the future I'll get the new tool for this type, or maybe I'll probably get the type of cable for the tool that I do have. But regardless, I don't have that tool right now. And, well, I'm gonna put this back in because getting these in and out actually it was not that bad. I got things to do, so let's put this in. I don't know what just happened, but well, I guess that's why you don't sit underneath this thing. So I had this thing hooked through here, and on this one, you can see that my loop is still there. Down here, this loop's still here, because it got through that little gap right there. Whole thing pulled through. Holy crap, we're not gonna hang it like that anymore. Yeah, I didn't want to hang it like that. I had it loop through in a hole like that, and I guess over time they slipped down. Oh, did I damage anything? Doesn't look like it. Yeah, it just looks like the old 4-wheeler frame landed on the jacks, but hey, that's why I have jacks. Good thing this thing only fell like, I don't know, 2 or 3 inches. Yeah, I just got the hook back onto the strap, and you can see it fell, yeah, about 2 inches. So I just loosely tighten this on here. Like you can see that's super loose still. Just so you know the wheels don't go floppy floppy while I push this out of the garage. So I thought I'd give you an update. I've done quite a bit of work now. One is that I did a bit more welding on the lower end of the steering. I know there was a comment that said that I'm not supposed to weld it, and I totally understand why. The only thing is I don't have much other of an option right now. If I can figure out another way, I will gladly change it out. But for the moment, I think I'm just gonna over weld it rather than, you know, just tack things in place. I still have up here I need to finish welding in, but you can see that this is a lot stronger. I still have some U-joints that need to be a little tightening, but you can see this bracket right there is flexing. This one's up here is flexing. That way, so when I do this, you can still see the tires moving, but I am getting a little bit of sloppy. So in a minute, I am gonna fix that up. So you can see I basically just marked a line there and with the grinder and just fairly easily, you know, scoured it. So now I can bend it down, that, and now this lines up right here. You can also see that on the other side, right here, I also scoured it and then, you know, push this down. I marked it to where the bearing is, so we're not actually hitting that. And so now when I weld right here, finish that weld in to right there, this thing is going to be a lot more stable, both because, you know, it'll be finished welding here, and we have, you know, obviously triangulation. So this is the very front U-joint, and you can see right here, I just found some of these triangle cutoffs, parts bin, and you can see I only have it like tacked there and right there. And so I think if I get these things lined up just right, I have one there, that'll strengthen this up a ton. So I'll weld that in, and I'll weld that cross member in. So I got these tabs welded in there like I showed you a second ago. And then right up here you can see that's all welded in, and that side is all welded in as well as the sides crossed around here. So now when I actually turn the stuff, look at this. No flex. I mean, that's, you know, the whole frame moving because, you know, I'm pushing on it, but way better. The tire's getting slowly deflated. If I do that, you can see it's got a little lump there. So let's fill it up just a little bit. Good. Now if I go to my steering wheel, aka my crescent wrench, oh yeah, way better. I think that's all the way that way we can go, yeah, because that compresses up. I'm not gonna lie, it's not exactly, you know, the easiest thing, but it is smooth now. So that's all the way that way. So yeah, steering is in now. It's actually in. This stuff arrived in the mail, except for this obviously, which is our old CVT Spline Shaft. But we have a 1.5 inch bearing there, a 3/8 inch keyway, a new sprocket, and this is 50 series chain. The reason why it's important to have these new parts is if we want to have the rear side chain driven, aka the transfer case to be chain driven, we need some way to convert this into having a sprocket on it. So this is a 1.5 inch sprocket, also 1.5 inch, and that's because this is 1.5 inch like we measured before, and this thing slides in there butter smooth. Same thing for right here. Now notice, can't go any further down, which would be nice if we needed that. However, I need it so that this sits on the end. I could, just weld this right here and then have the bearing be like that, but the only thing that's gonna be holding this would be like one little bead weld around there and on the inside. So my plan instead will be, since these threads are only a hair, I believe I would have to take this down by a 1/32, if I remember right. It's a 16th oversize. So I need to fill this in with weld, then I need to have this machined down. That way, so this will fit over it, and the reason why I'm welding it is to fill in all those gaps, because, I don't want to have this sitting on just the fine tip points of all these threads. So I'm gonna go out there now and I'm gonna weld up as much as I can of all this, and just like that, all those threads are welded up. This is extremely hot still, so I'm gonna set that down. You can definitely see I added a lot of layers, and yep, so now I just gotta put that in the new tool I got and put it in the mill. Yeah, that's still very hot. So this is my milling machine. It's a 1974, I believe, and I got it from basically a scrapyard. Me and my dad fixed it. However, we let it sit down here for maybe just before I bought the Leaf. We used it a handful of times, nothing where I used it a lot. And well, it looks like the CVT is a little stuck. Yeah, if I put it in the neutral, yeah, it's still stuck, which is how I know it's not the transmission side of it. And I took a look in the side panel. Looks like the driver side of the CVT is a little stuck. Now, we have had the CVT apart twice. And the last time they get it in, we zip tied this compression spring, and the last time we did maintenance on it was this exact same issue. One of the ends of a zip tie got stuck in the spring, stopping it from pushing the CVT back. So I don't know how we missed that, but it looks like we missed another one somehow. So it's jammed. It could be something else, but I gotta fix that real quick. So this is the rear side, the mill head. And so this is where the CVT spring lives. Okay, so there's a bolt right there. The best guess would be to remove that spring, drop this down, and see how the CVT spins. Okay, this might be really dumb, but I'm not sure. This is a block of wood that's right here. That's the spring I need to compress up. This is a bottle jack, and this was the smallest thing I could get in there. I'm going to jack the bottle jack up, try and get this centered first. While the spring pressed a little bit, I think I can get this bolt out. I know, this is a great angle, isn't it? Okay, that looks like it's out. Yo. Oh yeah, I forgot that spring, is compressed in there. Ah. Yeah, well, that spring wants to go down. Let's see if we can do a controlled twist. Uh-oh. 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 This thing's gonna twang. Well, if we're gonna... There we go. Now, this should not be stuck in there. That's the issue. Hey, we found our culprit. There was even more in there, look at that. So I just went and looked up through the side passageway that's up there, and I just realized the CVT is still stuck up. It didn't fall down, which is, there's a ring right here. I guess I'm just gonna whack it and see if it falls down, and then I'm just gonna have to make sure these grooves right here are oiled. That's weird. Oh, hey, yeah, you see that little ring up here? Okay, well I should be able to turn it on now then. Well, there you go. That's our issue right there. Oh, wow, it's sticky. Okay, well, let's get some oil on that. I just want this to be clarified. I'm not a machinist. I'm just someone who plays being a machinist, but I do know that this is non-detergent whey oil in here. I'm not putting this on the actual CVT, not the machinist. Oh yeah, much better. That's moving way better than it was before. That spins fine. Oh, did the belt adjust? It did, thank goodness. So I just spun the motor around by hand, and well, it seems to be spinning smooth in the front. So I don't know what would be causing it not to spin smooth, other than the belt sticking in the back because of this not, contracting back down to the zip ties. So I'm just gonna put it back together, see what happens. If not, well, we have a way to get this apart again. Yeah, this guy, yeah, see, this should just fall out. Holy crap, that starts down. Oh, I'm screwed. No wonder I used zip ties before. How do you do that? Uh-oh. Well, so I zip tied maybe the bottom few, not completely, so it just only requires 3 zip ties. That gets us up a lot higher. And now when I push, it's a lot easier to get it started. So I'm gonna go from there now. And that probably doesn't look right, and you'd be right. And that's because I dropped the bolt and it fell into, well, that bottomless pit that's in here, that's the entire housing, and I can't grab it right now. I don't have all of my tools with me. I don't have my telescoping magnet to grab down in there, so I found this other bolt. I measured the other bolt beforehand, thankfully. When I read it, it read 5/16 by 20, and I checked that. Since this whole machine is metric, I thought that was really weird, and apparently that's really, really close to M8 by 1.25, or 1.5, I can't remember. I did have a 5/16, so I screwed that in. It went in fine. Just this bolt is longer, needs to be, so I put this nut on it so I can tighten it all the way up. So this is not the proper way to do this in the slightest, but hey, I got the zip ties out perfectly, it's all in, and I'm gonna give it a spin test just to see if it works. Hopefully it does. Well, I'd say that spun up in high gear, so let's put this now into low range, see if it starts up. Well, I would say that's a good temporary band-aid fix for something that completely wasn't working before. So I'm not gonna put the cover on because it doesn't fit because of that. For now, let's get on to the next part. So now we can actually get to the part that we came over here to do, and that's to put the new dividing head on the mill because, well, I need to cut round stuff and I can't really do that without a lathe, so I got this. Oof, wow, that's not great. Hopefully everything's in here. 0, still dead on 0. So I know that actually is good. That moves maybe like 1/4 of a thou, which honestly, plenty good for me. Which given we're only machining about 1 inch, I think that'll be perfectly fine. All I did was I lined this up, I did 1 pass, you see a few chips, and well, yeah, that's basically what I'm gonna do, but the whole thing around. So let's do that real quick. I realize there's flat spots on this and it's hot. 39.07. In other words, is 1.5380. And we're aiming for 1.5. So we're about 38 thou over dimension. And to get to that final bit, I'm going to change out from my roughing bit to my finishing bit. We're at 1.502, so we're 2 thou over. I am gonna kick that in just a hair. I'd rather it be a hair under than a hair over, just because I'll get the sprocket on and off a lot easier. Unlock the table, move it in 5 thou, take another pass. Look now. Oh, just barely. Yeah, I can see it just get over the edge. We're right at 1.512, a little bit more. Okay, so I've crept up to the point where this is smooth. And this guy, it barely gets on there, but if you just tap it a little bit, it's really nice and snug. And honestly, probably a hair bit too snug, so I might go down just a little bit more. It does go on, which obviously we have a key. We want to make it a little bit looser than that, so I give it 1 more pass. So that's the 0. Measure the diameter, show you. See that, yeah. 1.4975. So I got really close up to it. So I filed the front edge very finely to get over that first little bump that was there. So now when I take this and I put it on, look at that. Look at that. Slides right on. So now all I have to do is mark where I want this keyway, and then using this guy, I'll cut that keyway in place. Go hair down more. Oh, that is absolutely perfect. Now I just gotta get the width. So this is a 1/4 inch end mill, and this is 3/8. So I need to go 1/16 more. I need to add to both sides. Could have gone a little bit more snug, but hey, fits in there. It's really nice. I went all the way to the end. See if it fits in there. Key fits perfectly in the sprocket. The key fits very nice in there. I see. Oh my god, that's what it was. There was a slight burr at the end of this. That is snug. Yeah, there's no movement in this now. None at all, in the slightest. Lock that keyway down, just like that. Now that's tight. And to do the finishing touch, let's mill this off. Look at just like that. Smooth. It looks like out there, but that's just rubbing. There's actually no texture there. But yeah, that's what we got. Wow, that is good and on there. Just to know that I did this correctly, or at least somewhat. Disassemble it, reassemble it. Because that is the whole point of doing all of this. I would have welded this straight on if I wanted this just, you know, to be straight on there. I want this to be able to just slide off like that. Oh, that's beautiful. Yeah, you can just see that's cosmetic. I rubbed it on. I don't feel it painting that. Just like that. So nice. It's time to get this out of there. Oh, it's so nice. Look at that. Fits in there like a glove. The point of doing all that is here's our bearing, here's our shaft. Look at that. Look how snug we can get those close to each other. That way, so all the load that comes from the chain goes straight through this bearing. Fantastic. And if we want to change this sprocket, we can just get a new one, plop it just on, just like we did this one. So now we just have to make a mount for this bearing that fits up to the rear transmission. See here, see this is our transfer case input. This is the output from our Jackshaft. So we need to add the sprocket here. It's the part we made last night. Transmission's in neutral, it's a little difficult to get on. And that's on. And I can get the old bolt and tighten this all down and on. But for the moment, let's not do that. Let's make a mount for this bearing. I can make some mount from the bottom frame down here up to the bottom here. And I think that's probably what I'll do, considering the other idea would be mounting it to the seat, which would probably not be the greatest of ideas. But yeah, but then it'll be easier to get the bolt and go down to here. And I don't think it'll interfere with the chain right here. No, we'll be fine. So now that hole lines up with that hole, and I just have to make another one for that, but I can drill a hole for that. Now I guess the next decision I need to make, do I want to have this bracket facing outwards, so I have the support brackets going that way, or do I want to mount it this way, to where it's easy to get to the bolts, and then there's easy way to make the brackets go back. So I think this way would be more supported, this way would be easy, but we should probably do it, you know, the more supportive way. So let's do that. Now I just have to make a bracket that goes from the back side of this down to that back beam down here. And it looks like that one's gonna be longer because it's farther, and this will be a lot closer. So I'll mark that out. So it's all bolted on now. I just put it into reverse. And if you see, if I do this, look at that. That's smooth. I put this back into neutral. Should be nothing. This should just spin freely, which it does. I'm gonna throw this into drive. If I can do this by hand. There we go, and that's drive. And the cool thing is if I twist this, you can see the whole frame move, which is pretty cool. now that the front chain is mounted, so is this rear one, and this whole jack shaft is now nice and tightened in. Obviously I haven't put the tensioners in yet. And then when I put the idler in here, so I can tension this all up, I'll build a cover plate. Not in today's video, but it looks like that'll work quite nicely. And I think I can actually just build a bracket off of the back bearing mount, put a spring on this, yeah, and push it down. Maybe I'll tension it from down here. I don't know. I just don't want to pull it up, because if I pull up, it'll hit the seat. So yeah, pushing down I think will work quite nicely. If I roll it forward and back, that chain won't move. Now if I put this into drive, that works quite nice. Put it into reverse. Cool. Just by the way, the chain is going in the correct direction. Don't worry, I did check that. Then if we put it back in the neutral, pretty sure I can get this into low. Yeah, it's spinning a lot faster. About twice as fast. Back in the neutral. And nothing. That's gonna be nice. So here's our jack shaft, front chain, rear chain. Obviously when I spin it, this one is nice and tensioned. This one's floppy still. That's because the idler sprocket that would go right here, tension it down. I haven't installed it, and I'm not gonna install it yet because I don't want it to interfere with any covering that I make for this. So whenever I make the cover, I'll make the idler sprocket mount on a spring, you know, that way, so it's always tensioning this. But to get that front chain tensioned, I did this monstrosity. So these are tensioners, and basically when you twist this around, it either makes these two separate out or together. And I have to design this a little bit better, but you get the general idea that when I twist this, it either pushes this bearing down, pulls it up, it pushes it down, it tensions this. If it goes up, then it loosens this chain. Right now I have it to where I've got a little bit of flex in it, but it spins pretty smooth. So for the moment, I'm going to leave it like that. This still needs some, you know, improving. This side doesn't even have a bolt through it because there's no hole there like that side did, and this one is a little bit, yeah, it moves a little bit. So I think that's gonna wrap it up for today. We put the jack shaft in, we fixed my milling machine, we did the machining for the rear spline so it can fit a sprocket. We put the chains on, we took apart the whole frame, that way so I could fix the front differential and replace all the bearings in it. We fixed the front axles, put everything back together, and then finally put the tensioner in for the jack shaft in the front. Oh yeah, and we also fixed the steering. That tire's still flat, but you can still see, you know, steering. Anyway, so I think that'll wrap up today's video. I think because these tires are causing me a giant mess, and I can't put the hub fluid in yet because I still have to put the front brakes on. So I think the next video of this will probably be brakes and tires. I think that'll make the most sense. So yeah, we got a lot of things done in this video. I hope you liked it. There's a playlist that I'm going to post up here in a second if you want to see how I got to this point. Otherwise, YouTube will give you a recommendation based off of what you like.